Hello everyone, this is Dr. Vaughn. I thought that I would do another quick screencast video demonstrating one of the problems. This is an even number problem again from section 8.1, getting started with functions. So the problem I've chosen, one of the harder ones from this particular section, has a rational expression here, 3x minus 1 over x minus 5, asks you to compute some different kinds of function values, then asks you a question about the domain. So I've put some of the values already in here, and these are already expressions in the equation editor, so I'll be able to just type in the responses as we go along. The main thing to not be afraid of in function notation is just the notation itself. All this means is we're going to substitute in 0 for each of the x's. So when we go to compute f of 0, I can put this as a rational expression, substituting 0 in for each of the x's. So on the top we have 3 times 0 minus 1. And you don't necessarily have to do this every time. You might want to write it out the first couple of times just so you can practice replacing the x with the value of 0. And then you simplify. So on the top you have 0 minus 1, and on the bottom you have 0 minus 5. So minus 1 over minus 5, which again you could write out. And this simplifies to be just 1/5. Okay, so for the second one, we do the same thing. We're going to plug in 3 for each of the x's along the way. This time I'm going to just skip a few steps because I think you get the gist of what's going on. So we'll just put in our rational expression. Plugging in 3 for x, you get 3 times 3, which is 9, minus 1 gives us an 8. And on the bottom, you have 3 minus 5, which gives you minus 2. And if you simplify that, you just get the value of minus 4. Okay, plugging in minus 3, you got to plug in minus 3 for both of the x's. So here you have 3 times minus 3 is minus 9 minus 1, so that's going to be a minus 10. And at the bottom you have minus 3 minus 5 gives you a minus 8. So minus 10 divided by minus 8 gives you a positive 5/4. And when we go to plug in x equals 10, we do the same thing. Sort of our rational expression. 3 times 10 is 30, minus 1 gives us 29. And at the bottom, 10 minus 5 gives you 5, so 29 over 5, and this doesn't reduce at all anymore. On this one here, part E, I didn't type it because I wanted to, again, demonstrate the use of the equation editor a little bit. So the problem itself says the function named f. Now, this is what I wanted to show you, is you can actually use this bracket instead of typing the parentheses individually. What this does is it actually expands the bracket to size it correctly, including putting a fraction in there for whatever kind of expression you want to put in here. So it'll make it longer or wider to adjust to whatever you want to put inside if you use the bracket operation instead of manually typing the percentage, the open parentheses and the closed parentheses, shift 9 and shift 0 on a traditional keyboard. So that's what I wanted to show you about this. The problem itself says to compute the value of f, where you plug in the expression a plus h. You really shouldn't, again, let this bother you at all. You're just substituting every occurrence of the variable x with now the binomial expression, which is a plus h. So again, we're going to have the fraction. We're going to set it up exactly the same, and you can actually even copy this if you want down over here. And then just go through and replace each of the x's. Let me make this a little bit bigger. Replace each of the x's with the value that you're plugging in for it, which is this expression a plus h. And down here, replace the x also with the value a plus h. So now, a lot of people get freaked out a little bit because this has all these variables in it, but you're just simplifying this just like we did in chapter 7. So you got to distribute the 3, you get 3a plus 3h minus 1 on the top. And on the bottom, you don't have to distribute, you can just lose the parentheses there, get a plus h minus 5. The important thing here is that none of the a's or h's cancel at all because you don't have a factor which is unique or the same in both the numerator and the denominator. You have addends that are the same, but not a whole factor to the entire numerator or entire denominator. So this really doesn't simplify anything more. Last part of this question asks the question, why must 5 be excluded from the domain? And of course, this is just, domain questions. You're looking for division by 0 and square roots of negative numbers in general. And when we get to logarithms, there's some extra things you have to do. But the value of 5 is exactly the value that's going to create division by 0. 5 minus 5 would give you 0. You can also solve for the value that's not in the domain by taking the denominator of the fraction x minus 5 and setting it equal to 0. X minus 5 equals 0 is the value that's not in the domain. So when I solve this equation to get x equals 5, that's the value that must be excluded from the domain. All right, so that's a simple function problem, evaluating this function at different numerical and algebraic expressions, and then a little bit about the domain of a function. Hope this has been useful to you, and I'll see you again next time.